Mm, Today we will learn about determinant of a 2 by 2 matrix. You will take any of matrix of order 2 by 2. So what is a determinant? Determinant is represented by DET from determinant. Determinant of A is written as, or what is the notation of determinant of A is like that. You will write the matrix in between two straight lines, and when you have to find the determinant of the given matrix, you have write the matrix in two straight lines like that. Now how can we find the value of determinant of A? The procedure is that you will multiply this first element with fourth element, and then second element with the third element, but between them we have sign of negative, right? In this way we will find the value of determinant of any matrix. In general, if you want to represent determinant of A, let's suppose that matrix A 2 by 2 matrix will be denoted by A, B and C, D. These are the four elements of matrix A. Then determinant of A will be is equal to A mod. This determinant of straight lines we will call it A determinant or A mod, right? How can we find the value of this A mod? We will write the matrix in straight lines, and then you will multiply AD and then BC, and in between these product we will write the sign of negative. It will give you some answer, and this answer will be whatever it will be, it should be a real number, right? In this way we can define determinant of a 2 by 2 matrix. Now after you have learnt about determinant, next will be two kinds of determinant. It will give you two kinds of matrix. Singular matrix, if modulus of A is equal to 0, then it is singular matrix, remember that. And if whatever you have matrix and its mod is not equal to 0, then it is a non-singular matrix. This is the new definition you will learn with respect to modulus or determinant. We have two kinds of matrices. If you will take the modulus of any matrix and your answer is equal to 0, then it is a singular matrix, right? And if you have given any matrix and you will find the determinant of that matrix or modulus of that matrix, it will give you the value not equal to 0, then it is a non-singular matrix. This is the new thing you will learn, right? And depending upon this singular matrix and non-singular matrix, we will learn about inverse of a matrix, right? So if we need to find the inverse of a given matrix, we should know about whether the matrix is a singular matrix or a non-singular matrix. For find out this singularity of non-singularity of a matrix, you have to find the determinant of that matrix. First of all, you will take the determinant. If your determinant is equal to 0, then it is a singular matrix, and for singular matrix you will find there will be no inverse of singular matrix. But if your given matrix have a determinant not equal to 0, then we will proceed further, and we have another formula I will tell you, and then by using that formula we can find the inverse of that matrix, right? Now after we have learnt about singular matrix and non-singular matrix, the next definition which I will tell you is adjoint of a matrix. Now what is adjoint of a matrix? Adjoint of a square matrix A, B, C, D is obtained by changing the entries of diagonals it means I will make in first place I will write D, and in fourth place I will write A. By changing the diagonal entries and by changing the signs of other entries, I will get adjoint of A, right? Adjoint of a square matrix is obtained by changing the diagonal entries and by changing the signs of the other entries of given matrix. For example, if I want to find the adjoint of this matrix A, which I have written earlier, A, B, C, D. So adjoint of A will be written as ADG for adjoint, and it will be found by D, A, changing the diagonal entries and by changing the signs of other entries. This is my adjoint of A, right? It's so simple. If for example, if I will take the example in numbers, let B will be matrix of 2 4 0 1, then what will be its adjoint? Adjoint of B will be, I am changing the diagonal elements and changing the sign of other remaining elements. So this will be adjoint of B, right? First of all, you will find the singular matrix or non-singular. I have told you how can we find the determinant of a matrix. After that, you will find the adjoint of a matrix like that. And when you will find the adjoint of a matrix, if you have to find the inverse of a matrix, then the formula of inverse of the matrix is adjoint of A is divided by A modulus. It will give you the value of A inverse, right? Now for example, I will take any example and then I will find the adjoint of A and then modulus of A, and if the modulus is singular, then the inverse will not exist because the answer will be 0 here, and anything divided by 0 is undefined. You know about it as infinity, so it can't be go further. But if your given matrix is a non-singular matrix, meaning it has some value 2 3 4 except 0, then you will proceed further and then you will find the adjoint of that matrix, and then you will use this definition in which you will divide adjoint of A by modulus of A. It will give you the value of A inverse, right? In this way we will find the inverse of any matrix. In next step I will take an example and then I will show how can we find the inverse of the matrix. Now in this step I will show you how can we find the inverse. They will give you question like that. They will give you a matrix and they will show you find A inverse. So whenever you have to find A inverse, the first step you will do, you have to find the determinant of this matrix. How can you find the determinant of this matrix? Just you will write it in straight lines and then you will apply the formula -4 multiplied by 2. Between them we have sign minus and 1 is multiplied by 3. Your answer is -11, which is not equal to 0. So you will write, so A is non-singular matrix and its inverse exists. After this you will find the adjoint of A. How can we find the adjoint of A? I have told you that we will replace the values of diagonal entries and we will change the signs of other entries like that. This is my adjoint of A. Now for A inverse, what I will do, the formula of A inverse is adjoint of A is whole divided by A modulus. Keep it in mind. Now 1 over A inverse will be here, modulus, and adjoint of A. I will put the value of modulus or determinant, and then I will write the adjoint of A, which is -4, -1, -3 and 2. So the answer of this will be -4 over -11, -1 over -11, -3 over -11 and 2 over -11. So its answer will become, minus will cancel minus sign, 1 over 11, 3 over 11 and 2 over 11. This is our A inverse, right? Now if you want to check whether your A inverse is right or wrong, you will keep in mind that A multiplied by A inverse, the answer should be identity matrix, which is 1 0 0 1. If you will get identity matrix, then your inverse is right. A, put the value of A, which is 2 1 3 -4, and then I will write the value of A inverse which I have taken, which I have found earlier. No, multiplication of this will give you now we will check. I think so we have done a little bit mistake here. This should be -2 by 11. Maybe I have done this multiplied by this, 8 by 11 plus 3 by 11. It's okay. This multiply 2 by 11 and 2 by 11. Yes, the mistake is here. 2 by -11, and here will be -2 by 11, and here will be minus. So here will be minus. Now you can check when we will take the LCM. This will cancel, this will cancel. Here is 0 0, and here again minus will multiply by minus, it will be plus here, right? So 3 plus 8 over 11, like that. Now you can check 11 by 11 and 0 0 and 11 by 11. A small mistake of any sign will lead you the wrong question, so please be very careful with your signs. So this is equal to identity matrix, right? So A multiplied by A inverse will be identity matrix, and it shows that our A inverse is correct. In this way you will find the inverse of a given matrix. It's so simple, so easy. If you can understand the determinant of matrix, adjoint of a matrix, formula is in front of you, and then you can easily get the value of inverse of a matrix. Hopefully you can understand it very well.